Hello there, exercise 10D.1. There's two parts of this, and I'll come back to that obviously in future. But today we're going to try to learn how to differentiate functions implicitly. And I should kind of get to the bottom of this as well. I've already got the answer on this actually, but I'll go through this one. So a little starter for you. The first answer is obviously cot x. I suppose the question is why, and all the other answers I want you to do. So pause the video, and then we'll come back and we'll see if you can do these questions. So I'll pause the video now. Okay, well, look, the first one, let's prove to you that this one is cot x. When you differentiate a log, a natural logarithm, you get 1 over. And normally it's 1 over x, but because it's the log of sine x, I get 1 over sine x. Of course, then, because this is the chain rule effectively, I have to multiply by the differential of whatever is in the bracket. And if I differentiate sine, you should remember sine cos minus sine minus cos. So if I differentiate sine, I get cos. So that really is cos x over sine x. And cos x over sine x really is, if you like, the tan x, but upside down tan x. So that's why it's cot x. The second one, again, it looks to me very much like a chain rule question. Whenever I differentiate these e's, it stays the way it is. E to the minus cos of 2t. But if you remember, I then have to times by the differential of this thing up here. And the minus cos, when I differentiate it, goes all the way back up again and becomes sine. And it actually becomes 2, because I've got a 2t here, it becomes 2 sine of 2t times by e to the minus cos of 2t. Let's see what my answer says. It's 2 sine of 2t e to the minus cos of 2t. Yes, right. Now tan, if I differentiate tan, I'm writing up here tan of x, I get sec squared. So I suppose that's important to remember. Now this is tan of y squared, so I immediately think, well, it's sec squared of y squared. But then I have to multiply by the differential of y squared. It's the chain rule. All of these seem to be the chain rule. So that's my answer for that one. 2y sec squared of y squared, yes. Differentiate. Notice this is another way of writing it. Find d dx of this. It just means differentiate. So I've got to differentiate cos. I've already got it up here. Cos becomes minus sine. So it's going to be minus sine of 2x plus 1. And then I have to differentiate the bracket. And if I differentiate the bracket, it's just 2. So I'm going to write that as minus 2 sine of 2x plus 1. Good. The next one is, it's a log again. So it's going to be 1 over this t squared plus 10. But then I have to multiply by the differential of this bracket, which is 2t. So I reckon it's probably just that, 2t over t squared plus 10. Yes, it is. Differentiate, right, this is the only interesting one. This is actually a product. So I've got u equal to y, and I've got v equal to sine of 2y. I need to do u dash, which is 1, and v dash, well, sine, over here, it becomes cos. So it becomes 2 cos of 2y. So remember the formula, it's u v dash plus v u dash. So if I do that, I get, you multiply on the diagonals basically. So I get 2y cos 2y plus sine 2y. See what my answer is. Written the other way around, but it's the same. Excellent. So nice little starter. Implicit differentiation is where something is not quite as obvious. I suppose it's implied, but not explicit. Now, explicit, for instance, here is an example of an explicit function. Y equals 3x squared. It's very clear what the y is and what how it relates to the x. But, for instance, this one, oh, sorry, this is explicit, and this one is implicit. Notice now it doesn't say y equals. So if you ever get like an expression for x and y where it doesn't say y equals, that, or x equals is equally good. But if it's kind of all mixed up and not clear as to what one thing is or the other, that we call that an implicit function. Now when we come to differentiate, we've just got to be a bit more careful. So it says here we're going to basically pretend it is what it says it is, and then we'll need to do some multiplication. So here's an example, for instance. If I am asked to differentiate y squared with respect to x, so I might have an expression, for instance, that goes x squared plus y squared. Didn't we have this just now on the last slide? Equals 4. Well, I'll just use that. Now, when I differentiate x squared, it's easy, 2x. And the temptation is, when you differentiate y squared, you also get something easy. It's 2y, but it's not. This is the bit that I want you to be aware of. What I do is I say it's 2y, but really I haven't differentiated it with the right letter. It says y's, and I'm differentiating with respect to x. So I'll write 2y dy by dx. And this 4, by the way, we can still do that. Differentiate 4, you get nothing. So these are the kind of expressions we're meant to do and how we're meant to do it. So let's do this one. X squared plus y squared, let's do it over here. X squared plus y squared. I'm going to differentiate this. Okay. Well, x squared is 2x. Well, in fact, it's very similar to the one I just did. Y squared looks like 2y, but then we have to put a dy by dx there. B, let's do B. Y plus x. Well, y just becomes dy by dx. Technically, I suppose it's, if I differentiate y, I get 1 dy by dx, but you don't need the 1. But I'll write it this time. The x, differentiate that, is just 1. 3x squared, it's easy, that's 6x. 2y cubed, well, it's a minus 2y cubed. Well, differentiate as if it's normal. I know the letter's wrong. And this is what you've got to do. Whenever the letter's wrong, you still differentiate it. So it becomes 6y squared, but then put your dy by dx. It says equals 1, so I'll differentiate the 1, I get 0. 2x plus 2y, yep. Dy by dx plus 1 plus 6x minus 6y, yep, perfect. Now, this is more like the proper exam question. Find the gradient function of the curve of this. For a start, gradient function, they mean find dy by dx, please. Give your answer in the form dy by dx equals some function of x and y. So they're quite happy for you to leave it as a function of x and y. Let's do it then. Differentiate log, I've already just said, where you get 1 overs, but it says log y, so it's 1 over y. But the letter's wrong, so I write 1 over y dy by dx. Equals, differentiate 1, well that's 0. Differentiate x squared, I get 2x. Well, just rearrange it, dy by dx. 2x is over here. Ignore the naught, obviously. Take, oh, not quite actually. I've just got to do a bit of work here actually. Well, not work, but I nearly went wrong. So I've just effectively crossed out that 0, and I've still got this 1 over y. I was going to move it over and make it a minus, but it's not, of course. This really means 1 divided by y. So if I move it over, dy by dx becomes 2x times by the y. That is my answer. This is a function of x and y, which is what that meant. 2xy, there it is. Given x squared plus y squared minus xy equals 2, find dy by dx. And in fact, they tell me what the answer is. There's a bit more after it. Well, anyway, let's do it. So differentiate x squared, I get 2x. Differentiate y squared, I get 2y. But the letter is wrong, so I write dy by dx quickly. Now these are the tricky ones. And these are what I would always expect. This is a product rule. Lots of people miss out the fact that it's a product. They forget, they don't spot it. So a product rule means I need to do a bit of work on this. The first one, u is x, and my second one, v, is y. I find my u dash, and I find my v dash. My u dash is just 1. My v dash is 1, but the letter's wrong, so it's y dy by dx. So what I need to do is I need to find, use the rule. The rule says u v dash plus v u dash, using that multiplication. So it's going to be minus the this bracket, and it's x times dy by dx plus the 1 times the y equals, differentiate the right hand side, 2 becomes 0. Oh, very often does, you'll get that. So this now becomes, look, there's dy by dx all over the place, so let's join them together. I've got dy by dx there, I've got 2y minus x dy by dx, there you go. got both the dy by the x's together kind of thing, and then move the 2x over. Actually, I've got a minus y. I move that over, that becomes more plus y. The 2x becomes minus 2x. And now you can probably see what I'm doing. Dy by dx I factorise. That gives me 2y minus x. Y minus 2x, and I just finish by moving that bracket onto the other side. Give me y minus 2x over 2y minus x. And that's the formula I want. Now it says hence find the value of the gradient when x is that. So x is that, y is that. So the gradient, I simply sub those numbers in. I get root 2 minus 2 naughts, that's 9, over 2y, which is 2 root 2, minus 9. So I think it's 1 over root 2. No, 1 over 2, sorry. The root 2's cancelled. So I think the answer is a half. A half it is. A curve is written like this. Show that dy by dx is this. Well, we just do the same thing. Notice, look, this is no surprise to me. This is the product rule. You so often get these products, and you need to spot them. So the 3x squared becomes 6x. That's easy enough. The minus 3y squared, well, hopefully you now know it's minus 6y, but it's a different letter, so I need to write dy by the x. Minus 3 is, well, plus nothing, if you like, equals nothing. The tricky bit is here. So I'm going to write u is 5x, v is y squared. U dash is 5, v dash is 2y. It's the wrong letter, so I need to write dy by the x. So if I do this, it's plus, well, I get 5x times 2y, that's 10xy dy by dx plus 5y squared on the other diagonal. Again, tidy up the dx by dy's, dy by dx, sorry, 10xy dy by dx minus 6y dy by dx equals, now I've got this minus 5y squared, plus 5y squared will move over and give me minus 5y squared. And I've also got this minus 6x. I don't like the fact they're both negative. I'll probably try my best to get rid of that. Take out the dy by dx as a common factor again. It's the same trick as last time. It gives 10xy minus 6y equals, I'm going to write it in the same order as them, minus 6x minus 5y squared. Of course, that's got a different shape to it compared to the answer they want. They haven't got minuses, so if I just write this minus 6x squared minus 5y squared, move the bracket over, and it's 10xy minus 6y. Now, I've got too many minuses, so change every sign. You write 6x plus 5y squared. 6y becomes positive, that becomes negative, so I've changed the order of those. And of course they have done that as well. So happy days. I've just written down the first stage of that, and I think I got that right. I'm not sure I'll be able to do all of this, but I'll start it at least. A curve is defined like that. Find the gradient. Well, let's differentiate x squared over 3. Well, that becomes 2x over 3. It says y squared, that becomes 2y over 4 dy by the x equals 0. And you'll notice 2 over 4 becomes a half, y over 2. Well, let's move it over. Y over 2 dy by dx equals 2x over 3. Move the 2, move the 3, dy by dx equals 2 2's are 4x over 3y. And it says find it at this point. Well, x is this and y is this. So the gradient at that point will be 4 lots of 3 over 2 over 3 lots of 1. Well, that becomes 2. That's 6 over 3. I think the answer is 2. Oh, negative 2. Where's my minus coming? It was here. It was a really stupid mistake. When I move that over, it becomes minus. That becomes minus. That becomes minus. And that becomes minus. Those are happy days. I got there eventually. look, I'm not going to be able to do that one, and that's the last one, so that gives me something to teach you in lesson. Other than that, I want you to try to do exercise 10D, and we'll do those in class. Thank you.